Okay, guys, let's begin with today's chapter here. First and foremost, if we introduce the energy chapter, guys, energy must be measured in joules, which is the units J here, right? Like joules, right? It's the units to measure energy. Now, in your syllabus, there are only three main forms of energy that you must know of. And those three main forms of energy with calculation, the first one is known as work done. The second one is going to be potential energy. And the final one here is basically going to be kinetic energy. Now, these three forms of energy are relatively more important simply because they have calculation in it. Let's go through one by one here and understand how do we use each and every one of these energies here. First and foremost, let's go into work done here. Now, work done has a very specific formula. Work done is equals to force multiplied by distance. And right off the bat, you'll notice that this formula here, right, kind of looks familiar with what we learned previously, right? Moments. Let me straight off the bat tell you right now, moment's formula is equals to force multiplied by distance, right? And work done, the formula is also known as force multiplied by distance. But the main difference between these two formulas is that if you think back about what a moment is essentially a turning effect, right? Like for example here, if today this is the force, this will be the distance that causes the seesaw to turn in this. This is essentially a moment, right? You'll notice that, guys, the force and distance for the moments usually they are perpendicular to each other. Key thing here is for moments, you must understand that it is force times perpendicular distance to the pivot. Usually, they will be in a perpendicular direction. But for work done, you must understand that work done, the only difference between them is that the force and distance, they must be parallel to each other. So what is an example of work done? Let's say, for example, today, if let's say I am standing here and I have a block here, this is the ground. I want to apply a certain force to it. Let's say I apply a force of 100 newtons. And this block, right, moves a certain distance. Let's say it moves 5 meters here. From here, I can calculate the energy I have exerted onto this block. And obviously, in this scenario here, it will be 100 multiplied by 5, which will give me an exact units of 500 joules. It means to say, in order to push this block with 100 newtons by 5 meters, I have to exert a total of 500 joules to get the job done. Essentially, this is my work done to push the block. Now, let's just imagine a different scenario here today. Let's say today, right, this block is already against the wall already. And if I was standing here and I apply a force of, let's say, 1 million newtons, do you think there will be any work done here? I'm pushing it like crazy. I'm sweating like crazy already.
There is no more space for it to push it.
Good, very good. There is no space for it to move. Essentially, that means to say there was no distance covered by the box, right? Now, it doesn't matter how much force I can apply to it. I could apply like the God universal force onto this thing, right? But as long as it doesn't move, then there's considered to be no work done. I'll be exerting a lot of strength onto it. It's like trying to push the thing against the wall harder and harder, but essentially there will be no work done because there is no distance. What if I have an absolutely God-forsaken scenario? What if today I push this thing towards the right, and this box somehow moves upwards? Will there be any work done? Absolutely not. Why? Once again, is because just now I mentioned, right, for work to be done, the force and distance, they must be parallel to each other. If for some God-forsaken reason, suddenly you push like this here and then it moves this here, right? For sure it doesn't work. Right? It will be considered more a miracle than the work done. So from here, first thing you need to understand is that work done is force multiplied by distance. The distance and force must be parallel to each other. And it obviously is measured in joules as well. Okay, so this is the first thing you need to know.